Hello, in this video I'll be speaking about requirements analysis. This unit covers three main areas which coincide with your learning objectives. You will need to differentiate between the types of requirements, understand how to gather and elicit requirements, and demonstrate how to document requirements using techniques such as use case modeling, writing formal use case descriptions, and writing user stories. I will speak about the types of requirements in this video. Please note that these videos cannot cover all the slides, so please study the slides on eCanva. As a reminder, we look at the systems development lifecycle again to see where in the process we are now. Remember, as we progress through the module, we also refer to the stages of the SDLC. As you can see, this phase comes after the planning and before the design phase. This is where you develop the business requirements document, or the BRD, or also known as the functional specification document. Requirements analysis involves two main processes, namely the gathering and elicitation of requirements and the analysis and documenting of requirements. There are three types of requirements that we will look at, and these map to the management and decision-making levels within the business, and each differing in the level of detail. The first type of requirements are business requirements. These are high-level requirements describing the overall scope of the project, and these are usually documented in the business case document, or BCD, a proposal, a project charter, or so forth. The second type of requirements are called stakeholder or user requirements. These are always written from the user's perspective and are documented using techniques such as narrative text, use case diagrams, scenarios, or user stories. The last type of requirements are system or solution requirements. These are the most detailed because they explain exactly what the system must do and how the system must do what it must do. System or solution requirements are further divided into two kinds, namely functional and non-functional requirements. A scenario is a narrative description of what people do and experience as they try to make use of computer systems and applications. Scenarios can have many different uses during the software lifecycle. Here we can see that in the requirements elicitation phase of the SDLC, the as-is and visionary scenarios will be used. In client acceptance testing phase, the evaluation scenarios will be used, and in the system deployment phase, training scenarios will be used. Examining the four types of scenarios a bit closer, we see that as-is scenarios describe the current situation of a user's perspective. Visionary scenarios describe a future state or envisioned situation. This is usually used in the greenfield or re-engineering projects. Evaluation scenarios are situations against which the system is to be evaluated, and training scenarios are linked to requirements and are step-by-step instructions to help a novice user become familiar with the new system. Most of a BA's focus will be spent on defining and documenting system requirements, so it is important that you understand the fundamental differences between functional and non-functional requirements, and that you are able to identify each of them from a case study. We can distinguish between functional and non-functional requirements in the following way. Functional requirements describe the interactions between the system and its environment, independent from implementation. So what must a system do in order to function outside of a particular domain? For example, the system must allow a user to log in with a username and password. A non-functional requirement are the constraints placed on functional requirements. For example, the system must verify the user's credentials within 0.1 seconds, or the system must provide a response within 0.3 seconds. The functional requirements are compulsory or mandatory. It is what the system must do. If the system does not perform that particular function, then the system is broken. The non-functional requirements are not compulsory. If the non-functional requirement is not there, the system may still be working. However, the non-functional requirements usually add extra performance characteristics, quality, efficiency, effectiveness attributes to the functional requirements. An example of a functional requirement would be that a system must send an email whenever a certain condition is met. Example, the customer placed an order, the customer signed up for a particular form, etc. A related non-functional requirement for that particular functional requirement may be that the system must send emails with a latency of no greater than 12 hours for that particular activity. The functional requirement is describing the behavior of the system as it relates to the system's functionality. The non-functional requirement elaborates a performance characteristic of the system. However, you can see that if the system takes longer than 12 hours, it doesn't mean that the system is broken. So non-functional requirements are not mandatory. The functional requirements are mandatory. There are different types of non-functional requirements, and you can see that they relate to all of the added features of a system, like availability of a system or the uptime, the efficiency of how the system works, how the CPU works, etc., flexibility of the system, the integrity and security attributes of a system, the performance and timing of a system, reliability of the system's frequency and sensitivity to tasks, reliability in the sense that there's minimal failures, etc., reusability of certain features of a particular system, robustness of a system, scalability in terms of demand, and the usability from a user's perspective in terms of ease of use and general user friendliness, etc. Requirements also need to be verifiable. So if you're looking at the three examples on the left hand side here, the system shall work satisfactorily. That statement cannot really be measured and it cannot be verified. It's a subjective statement. So being satisfactory is dependent on the user. So we wouldn't want to have a statement like that. The second one as well, the interface shall be user friendly. That can differ from user to user. So the expectation of each user in terms of user friendliness will differ. So that is not a verifiable statement because it cannot be measured and tested and verified. The system shall respond in real time. Again, this is a very subjective statement because real time changes based on time zone. On the right hand side over here, there are three examples of more verifiable and more specifically written requirements. The output shall in all cases be produced within 30 seconds of the corresponding input event that can be measured, tracked and traced. It shall be produced within 10 seconds for at least 80% of input events. Again, can be tested, can be tracked, can be traced. Professional trained drivers will reach level 1 of proficiency defined in the requirements. So level 1 will be defined in 2 days of training. Again, that can be measured. It is a verifiable statement. Sometimes a project cannot implement all of the requirements for a whole variety of reasons. Once you've established that some requirements will have to be dropped, the question arises of which requirements can be dropped safely and still ensure that the project will achieve its objectives. A technique known as the Moscow Prioritization for Requirements technique can be used to identify which requirements can be dropped safely without compromising the project. So under the M, we have must-have requirements. This is very straightforward. Can the project achieve success without this requirement? Yes or no? These requirements tend to be few and very obvious. For example, in the statement record sales, the solution, if the functional requirement is to be able to record sales is dropped, the project can in no way succeed. So most functional requirements will fall within the should have category. These contribute to objectives, but without them, the objectives can still be achieved. The priority of a functional requirement in this category can also change. Sometimes, suppose that a project is being forced to drop requirements. There comes a point where dropping a should have requirement means that the project cannot achieve its objectives if that particular requirement is dropped, then that requirement becomes a must-have requirement. Could have requirements. This requirement only maps to one or more principles of the project, so the project can still achieve success, and therefore this particular requirement can be easily dropped. A wish list requirement does not map to any project objectives or principles. There is no hard or soft benefit to implementing this requirement. It is only being done as perhaps a favor or on someone's wish list. So this requirement can be dropped with absolutely no negative impact on the project or on the solution. So not only can you prioritize requirements, but only the should have requirements should be debated. The must-haves must be kept, and the wish list and could-have requirements can safely be dropped if the project needs to. Here we have examples of functional requirements per category. You can see the printing and the spell checking category. Notice the numbering and notice how the requirements are written. Requirements need to be written in a very specific format. Ensure that requirements map to specific project objectives. Ensure that there are no technical solutions in your requirements. For example, if the requirement is for the system to send an alert message to the customer, don't say the system must send an SMS to the customer. Change the word SMS to messages, because that allows the solution designers to think about the most efficient way of getting the message to the customer. Ensure that there is only one functional requirement per statement. Never use words like and or but, however. You cannot track, prioritize, or identify who generated the requirement if one requirement statement has more than one requirement in it. For example, the solution will record and report on sales. Either record and report are the same thing, in which case just drop one word and write it as one statement, or they are actually two requirements and they need to be performed and tested and tracked separately. So you would want to write the solution will record sales and the solution will report on sales as two separate requirements. Ensure that requirements only answer the question, what will the solution change in order to achieve the project objectives? Nothing else should be recorded as requirements. Requirements must be written out as full, definitive, accurate, and as complete as possible, but only in order to answer the question we are analyzing when analyzing functional requirements. So again, what does the solution need to change in order to deliver the requirements? Then, these are examples of non-functional requirements. Spectators must be able to watch a match without prior registration and without prior knowledge of the match. If these are two separate functions that needs to be tested separately, then this needs to be written as two separate requirements. This is an example of a usability requirement. The system must report 10 parallel tournaments, an example of performance requirement. And the operator must be able to add new games without modifications to existing games. This is an example of a supportability requirement. So here are some more examples. Notice requirements ID, which is important for traceability of requirements, especially in the test cases, and we will talk about later. Also notice the risk factor and priority index. And lastly, also see that there is a reference to other requirements that may be dependent on these requirements here or vice versa. Lastly, do a checklist to see that the requirements are correct, the requirements are complete, there is consistency, are there any requirements that contradict each other, that there's no ambiguity, the requirements are written clearly, it's real requirements that can be implemented and delivered properly, and that it can be traced throughout the SDLC. That is all for this video. In the next video, I will be speaking about gathering and eliciting requirements.